Hi everyone. Okay, nice to meet you again. Welcome to my channel. Please don't forget to subscribe this channel by click on the link below. I know it sounds cool, right, to say those kind of things like YouTuber. Even I'm not a YouTuber, okay, but okay. So last time we have done the transformations of points, graphically. So this is what we got. From 2, 3, 12, 6, 10, 12, it becomes negative 6, negative 3, negative 1, negative 4, and negative 2, negative 6. But you want to learn more instead of just having graphically, because sometimes graphic can be irritating. What I mean by irritating is this. Sometimes when the number is so big, or when it puts to the decimal points, and sometimes you'll have an error when you do the graphic. And we try to avoid that by having the second way, which is algebraically. So I'm going to teach you on this lesson how you can do the transformations of points algebraically. Okay. The idea is still same. Okay. So this is the problem. And you have these points. There are 3 points. It can be more, but I just put like 3 points, and then it has dilation, translation, reflections, and rotations. Before we try to do that, what you need to do is to have the matrix multiplier. So what I mean with matrix multiplier is that later these points need to be times with the matrix multiplier. Okay, so there is a matrix multiplier for the dilations in x directions by half and by y directions by 1/3. What is the matrix multiplier? There will also be matrix multiplier for reflections, and then the last one, there will be also matrix multiplier for rotations. So what are they? Dilations. Then for the dilations, which I already give to you, you have k0, 0, k. Now this works if the number of factor is same in x and in y. But since you have in x directions by half, the y directions by 1/3, then what you'll need to put is, this will be half 0, 0, 1/3. Okay, so that is the matrix multiplier. For the translation, like what I a few days ago, I teach you that we are not going to use the matrix multiplier for the translations. So we'll just add it, as usual. So I'll just leave this alone. Reflections by y equal negative x. Then you'll have 0, negative 1, negative 1, 0. That is the reflections by y equal negative x. So try to open again your notes if you have a note. So you'll find that this will be 0, negative 1, and 0. And then the last one, rotations by 90 degree counterclockwise. This is what we are going to have. We'll get cos theta, and then cos theta plus 90 degree, and sin theta, and sin theta plus 90 degree. Again, for the theta, it will be positive if it is clockwise, but if it is, let me repeat it again. If it is if it is counterclockwise, then you will have positive. If it is clockwise, then it will be negative. That's for theta. Okay, so in this case we have counterclockwise, so it will be positive. So this is what we'll have. We'll get cos 90 degree, cos of 180 degree, sine of 90 degree, and sine of 180 degree. Okay, we can simplify that. Cos 90 degree, you have that. Okay, so it will be 0 at cos 90 degree. Cos 180 degree will be negative 1, and then sine 90 degree. Sine 90 degree will be 1, and then sine 180 degree. 180 is 180. It will be 0. So try to remember sine. It will be like this, right? In fourth quadrant, this is sine. For cos, you will have something like this, right? In 4 quadrant, 1, 2, 3, 4. Yeah, this is cos. So it makes you easier to determine whether it's positive, negative, 1, 0, or negative 1. Yeah. So this is the matrix multiplier, and then we have A as a matrix. Then what we do? So yeah, I'll put the calculations over here. So let's say if we have A, the first transformation that we have is dilation, right? So dilation, it says that you have half, 0, 0, 1/3. So I times it with the dilation over here. Okay, and then after I have the dilations, then it goes to the translation. So I add it with the translation. Yeah, I added the translation. So this result and then added the translation. Then I get the reflections. So to get the reflections, is the third one. Then this result will be times with y equal negative x, which is 0, negative 1, negative 1, 0. So this is the reflections, RE. Okay, I put it over here. And then last one, after the reflections, I'll get the rotations. Yeah. So we want to know if this result will be equivalent to that one that we use the algebraic way. Okay. So let's just put the numbers. Rotations, you'll have 0, negative 1, 1, 0. The reflections, you have 0, negative 1, negative 1, 0. Yeah. And then times with the dilations inside, you have half, 0, 0, 1/3. Yeah. Half, 0, 0, 1/3. And then we have the A, right? So I'll just write it again. 2, 3, 12, 6, 10, 12. And then add it with the matrix of negative 7 and then 2 over here. Yeah. Okay. You can do the multiplication of this one and then just times it with these two distributive. But I would prefer to do simultaneous. It means that do it at one time. Okay? So I'll do these multiplications and then I'll do after that at the same time these two matrix multiplications and then add it and then combine it. Okay, so this is what we are going to have. 0, remember the multiplication of matrix 0, negative 1, 0, negative 1. Then you'll get that this will be 1. Yeah, 0 times 0 added with negative 1 times negative 1. Yeah, and then for this one, 0 times negative 1, negative 0, negative 1 times 0, that will be 0. Yeah. Next element, 1 times 0, 0, 0 times negative 1, 0. Okay, and then 1 times negative 1, that will be negative 1 added with 0. So this is what you have from these two multiplications. Yeah. And we have also over here, this is the dimension of half 0, 0, 3 is 2 by 2 matrix. 2 rows times with 2 columns. This one is a 2 by 3, 2 row by 3 column. Now the result will be 2 by 3. So you just look at the first and the last number over there. So 2 by 3. Half 0 with 2 and 3. So half times 2, you'll get 1, right? Added with 0 times 3. So basically, it's like a half times with this row. Yeah, so 1, and then you'll get that this is 6, and then this is 5. Okay, close this one. And then 0, 1/3. 0 times 2, added with 1/3 times with 3. So basically, the second row will contain 1/3 times with this from the multiplications of matrix. So you'll get that this is 1, this is 2, and then this is 4. Yeah. And then added with negative 7 and 2. Remember that these two are additions. I don't put negative 7, 2, 2, but I hope that you understand that I use a different symbol to say that from here, so it means that 1 added with negative 7, you'll get negative 6. 6 added with negative 7, you get negative 1. 5 added with negative 7, you get negative 2. Yeah. And then you have 1 added with 2, you get 3. This will be 4, and then this will be 6. Okay, then we times it with 1, 0, 0, negative 1. So, what's the result? We'll have 1 times with negative 6, and then 0 times with 3. And then we add it, we get negative 6, negative 1, negative 2. And then 0 times with negative 6, added with negative 1 times with 3, so you get negative 3. On the second row, we'll have the negative. Yeah. So if you try to compare negative 6, negative 3, negative 1, negative 4, negative 2, negative 6 with what we have algebraically, we'll get the same result. So both you do algebraically and graphically, the result is supposed to be the same. I'll end the lessons up to this point, so I hope that now you'll be able to transform the point graphically and algebraically. Thank you.